If you want something to play with, go and find yourself.
And number 8 asks us to evaluate from 1/2 to 1 dx over x squared times the square root of x squared plus 4. Okay, so you can see how on the bottom this resembles the x squared plus a squared, right? So our a in this case is going to be 2, because 2 squared equals 4. And our side equations are going to be 2 tangent theta equals x. And so dx equals 2 secant squared theta, d theta. And our square root, so a squared is now 4, right? That equals 2 secant theta. Okay, so when we rewrite the integral, we're going to have dx on top, so that's replaced by 2 secant squared theta d theta. And on the bottom we have an x squared, which is actually 2 tangent theta all to the second power. So that will turn out to be 4 tangent squared theta. And then times the square root, which is replaced by 2 secant theta. Alright, so already we see we can cancel the 2 on top and 2 on the bottom, and 1 of the secants, right? So this is what we're left with, is, I'm just going to bring the 1/4 out, and then we have secant over a tangent squared. So that's actually going to be, like tangent on the bottom, that's like cotangent, right? So this is going to be a cosine squared theta over a sine squared theta. So that takes care of the tangent part. And then we still have a secant on top, which is the same thing as 1 over cosine. And then our d theta is at the end. Okay, so we can cancel something else, actually, 1 of the cosines, right? So now we're left with 1 over 4 times cosine is left on the top, and we have a sine squared theta on the bottom. Okay, so here's where we can turn to u substitution. So we can make u be sine theta, and du is then cosine theta d theta. So d theta, if we divide the cosine over to the bottom, is going to be like this, right? Okay, so then if we rewrite it in terms of u, then this integral turns out to be, so arrow, this turns out to equal 1 over 4, and then our sine theta is to the -2 power. So this is like u to the -2. And then we have our cosine theta, and in place of d theta, we're going to have du over cosine theta. Du over cosine theta, which is really nice because then, again, cosines can cancel. And we're left with 1 over 4 integral u to the -2 times du. Okay, so now I'm going to go on to the next slide, and this is going to equal 1 over 4 u to the -1 with a negative sign in front, right? Okay, so then now we have to replace the u with what we subbed out for it. So u, remember, was sine theta. That's what we made it. So this is actually 1 over 4 times, well, this is a -1 over 4, right? I'm just going to bring the negative out. And then this is a 1 over sine theta. Okay? And now that we have theta, well, okay, yeah, we can't put in the bounds just yet, like the 1 over 2 to 1, because we're still in terms of theta, and the bounds that they gave us were in terms of x. So we can't do that until we convert back to x's, which we will in a minute. So this sine theta, remember we have to, like I just said, we have to replace with x's of some sort. So replace with x's. Okay, so here's where actually some trigonometry comes into play. So what we do have, to figure out what sine theta is in terms of x, we have to play around with the equations that we formed before. So the one that I'm going to look at in particular is secant. The secant theta that we had, we found that 2 secant theta is equal to the square root, right? So then secant theta itself, if we get it by itself, then we're going to get this square root, x squared plus 4 over 2, right? And then as we recall from our trig classes, secant theta equals 1 over cosine theta, right? And cosine, as we know, is adjacent over hypotenuse. So let me draw a little triangle to the side here. Okay, that was a pretty straight line. Not the second one, but okay. So pretend this is a right triangle. Yeah, okay. So here's your right triangle, and then here's theta, and we have adjacent, adjacent side, opposite side, and hypotenuse, right? So 1 over cosine would actually be hypotenuse over adjacent, right? This is actually the formula for secant. So hypotenuse over adjacent. So our hypotenuse must correspond to this radical, right? So we can write it like this. And then our adjacent must correspond to the 2 down here. So that's like down here. Okay, so we can solve for the third side just by doing Pythagorean. And we get that this side is simply x. Okay, the height is simply x. And now we can solve for sine theta. Okay, so sine, as we know, sine theta equals opposite over hypotenuse. Okay, so in this case, sine theta equals opposite, so x, over hypotenuse, which is our square root thing. Okay, so now we know this. Except for when we plug it in, see how sine is on the bottom? So we're essentially going to have to flip this over anyways. Alright, so I'm going to go on to the next slide. Okay, so now we have our negative 1 over 4 times, and we said we're going to flip it over because sine was on the bottom, remember? So the square root's on top, and then on the bottom we just have x. Okay, so as you can see now, we've translated or like transformed back into x, right? So now we can write in our bounds and evaluate. So once we do this, we have our negative 1 over 4. I'm just going to keep that outside, or maybe not. Okay, I'll just evaluate it with it. So then we have square root of 1 squared plus 4 over 1. Okay, and then a minus negative 1 over 4. Sorry, I have dogs in the background. Yeah, I mentioned before I have dogs. So this is going to be a minus, and then we're going to plug in the 1/2. So this is going to be 1/2 squared. I'll just write it like this, and I'll simplify later. And then over a 1/2 on the bottom, right? Okay, so doing the math and everything, we're just going to get, well, I got a radical 17 from here, and then minus 5 over 4. And you can check the math on that. That is what I got, so hopefully it's correct. Okay.
Tell it like it is. My time is too expensive, and I'm not your little boy.